Hello everyone, welcome to the question practice session for NEET 2025. This is the part 1 of solution in which we have seen yesterday the let's try on our own section. 5 questions were given to you that you were asked to try, and let's discuss those 5 questions today. I hope you have tried on your own. Let's see the questions, what they are saying. Fine. The first one, 2.5 liter. So these are the given thing. Let's highlight 2.5 liter of 1 molar NaOH solution is mixed with 3 liter of 0.5 molar NaOH solution. So till this much, what we see that 2 NaOH solutions are mixed. Okay. The first solution is of 1 molar strength, and what is the volume? 2.5 liter. This is a NaOH solution. It is mixed with another NaOH solution whose strength is 0.5 molar, right? And what is the volume? 3 liter. This is also another NaOH solution. Both are mixed together. We need to find out the molarity of the resulting solution. So after mixing, we are getting a resulting solution. We have to find the molarity of this resulting solution. So obviously NaOH mix, finally what we are getting? NaOH. They didn't say that we are adding extra water or something. Simply the first one and the second one is mixed together. So after mixing, what do we see? The volume V3 should be what? It should be equal to 2.5 liters plus 3 liter. That is 5.5 liters, because we are simply mixing two solutions. We are not adding any water. Such kind of informations are not given. So we need to find what? We need to find the M3. What formula can we apply? M1 V1 plus M2 V2 is equal to M3 V3. Right? The other informations we have, only we need to find the V3. Let's put everything. M1 is 1 molar, V1 is 2.5 liter plus M2. What is M2? 0.5 molar. What is V2? 3 liters is equal to M3 we have to find out. And what is V3? 5.5 liters. Right? So if I have to find M3, it is equal to 2.5 into 1 is 2.5 plus 0.5 into 3. This is 1.5 divided by 5.5. What is this? This is coming as 2134. So 4.0 divided by 5.5. So I can simplify and write this as 40 divided by 55. So I can use 5 to cancel out. This is 11. This should be 8. So this is coming as 8 by 11. So finally, how much will be getting here? 0.72. Okay, this is the molarity of the solution which is formed by mixing the other two NaOH solution. 0.72 or 73. That is option C will be our answer. Hope you got the answer. Similar kind of questions we have already discussed yesterday. So this is a simple formula used. Yesterday we have seen that water was used to dilute also. Those kind of questions we have seen. Here no extra water addition was there. So directly we have done it. Fine. The next one. The weight of glucose present in. So you have to find what? Weight of glucose. Okay. What is given to you? Present in 500 gram of 0.5 molar aqueous solution. Okay, mass of the aqueous solution is given 500 gram and molarity of the aqueous solution, molality of the aqueous solution is given molal. So molality is given 0.5. Fine. We know that molality is equal to what? Given mass of the solute divided by molecular mass of the solute into 1000 divided by mass of the solvent. Right? Mass of the solvent. Now molality is given. What is the molality? 0.5 molar. Okay, given mass we need to find it out. Molecular mass. Now The solute is what? Glucose. What is glucose? C6H12O6. This is glucose. We can easily find the molecular mass. Carbon's mass we know is 12. How many carbons are there? 6. Hydrogen's mass we know 1. How many hydrogens are there? 12. Oxygen's mass is 16. How many oxygens are there? 6. Okay, so if we calculate, this is 72 plus 12 plus 16 into 6 is 96. So 6, 7, 8, 9, 10. This is coming as 180. So molecular mass of glucose is 180 into 1000. Mass of the solvent. Here we have this 500. 500 is the mass of the solution, aqueous solution, not the solvent. So we don't have mass of the solvent here. We don't have mass of the solvent here. We need to find out. So let's suppose the mass of the solute which is taken is X. What we are supposing? Let the mass of solute, that is glucose, is X gram. Okay, mass of the solute is X gram. Total mass of the solution is given to you is 500 gram. So what will be the mass of the solvent? 500 minus X gram will be the mass of the solvent. Okay, solute we have considered as X gram. Total is given 500 gram. So obviously for solvent it will be 500 minus X. So like that only we'll put into our formula that we are using. So X divided by 180 into 1000 divided by total mass of the solution was 500. We have considered the mass of the solute as X. So minus X will be the mass of the solvent. Done. Let's cancel the 0, 0. So what we are finally getting? This is 0.5 into 18 divided by 100 is equal to X 500 minus X. Okay, 0.5 into 19. So we are getting 19, 9.0. So this is, point is there. So 9.0 divided by 100 is equal to X by 500 minus X. Okay, so finally again if I remove this one, okay, do it here. So this will be equal to what? 0.09. So 500 minus X, I can write like that, is equal to X. Okay, I brought on the other side. So 0.09 into 500. How much finally will be getting? 45 minus 0.09x is equal to X. Fine, we have multiplied. Then we'll take 0.09 on the other side. So finally what I'm getting? 45 is equal to 1.09x. Okay, I'll get like that. So X will be equal to what? 45 divided by 1.09. So finally the X value I'll get as 41.28 gram. This is X value. What was X? What did I take X? X is nothing but mass of the solute. Mass of the solute. What was the question? Weight of the glucose. Glucose is the solute. So X is 41.28 will be your answer. So your answer is C, 41.28. Done? Simple calculation. So please don't get confused. 500 is the molar aqueous solutions mass. Aqueous solutions mass, not solvents mass. So we have found out, we have taken X as the solute's mass. So total mass of the solution was given. So finally for solvent, our mass was coming out as 500 minus X gram. Okay, don't get confused with that. So my option here is C. So 15. What is the molarity of H2SO4 solution? You need to find what? Molarity of H2SO4 solution. Okay, what is given to you? that has density is given 1.84 gram per centimeter cube at 35 degrees Celsius and contains 98% by weight. So this H2SO4 is 98% by weight. This kind of questions yesterday we have done. So whenever this H2SO4 is 98% by weight, means 98 gram H2SO4 is present in 100 gram of solution. This is the meaning of 98% by mass or by weight. This is the meaning, right? We need to find what? Molarity. What is molarity? Given mass by molecular mass into 1000 divided by volume of solution in ml. This is molarity formula, right? Now let's find given mass. Just now we have seen it is 98 because 98% given. So 98. What is molecular mass for H2SO4? H2SO4. So hydrogen 2, sulfur 32 plus 16 into 4. So finally how much we are getting? 98. 98 is the molecular mass also for H2SO4. 98 into 1000 divided by volume. Is volume given to us? No. Volume is not directly given to us, whereas density is given. Right? We'll convert. Now density is equal to what? Mass per unit volume. Volume is not given to us. So volume will be equal to what? Mass. What is the mass? This is the 100 gram given from that statement. So 100 gram is the mass divided by what is the density? Density is 1.84 gram per centimeter cube, or we can also write as ml. Yes or no? 1 centimeter cube is equal to 1 ml. So like that also we can write. Done? So 100 divided by 1.84 will be equal to 54.34 ml. So this is what? This is the volume. Let's substitute the volume here. So 54.34. 98 to got cancelled out. So this is 1000 divided by 54.34. This is coming out as 18.40 molar. 18.40. This is the molarity of the H2SO4 solution whose informations are given: density, 98% weight, etc. So 18.40. Which one will be the option? Option A is the correct one. Done. Next one. Concentrated aqueous H2SO4 is 98% by mass. Okay, again this information is given. H2SO4 is 98% by mass and has a density. Density is given to you 1.80 gram per ml. Volume of the acid required to make 1 liter. How much you have to make? 1 liter of 0.1 molar H2SO4 solution. What you need to find is the volume. How much volume do you require? So understand this kind of question also yesterday we have solved. So there was a stock solution. There was a stock solution. Okay. Now this stock solution, this stock solution is how much? 98% H2SO4 by mass. Okay. The stock solution is 98% H2SO4 by mass, and also the stock solution's density is given to us. How much? 1.80 gram per ml. This is the stock solution. From this stock solution, how much volume should I take out? How much volume of this stock solution should I take out in order to make a H2SO4 solution? In order to make a H2SO4 solution, whose volume is 1 liter, okay, and whose strength is 0.1 molar. So we need to make a H2SO4 solution whose strength is 0.1 molar and volume is 1 liter. For making this, I need a stock solution. The stock solution's informations are also given to us. Right? So let's start. Molarity of the solution that you want to make is given to us. With this we can find the mass. With that we'll find the volume. We'll relate and we'll find. Right? We know molarity is equal to what? Given mass of the solute divided by molecular mass of the solute into 1000 by volume of the solution in ml. This is the formula for molarity, right? Given mass, we don't know. Molarity is given to us, whereas 0.1 molar. Given mass, we need to find out. Molecular mass of H2SO4, so many times we have calculated. It is coming as 98. You can also calculate and check. Into 1000 divided by volume. Okay, volume is directly given in liter. So let's not just divide with 1000. Simply we can take the volume as liter. So 1 by 1. So let's simplify the formula also, because the volume is already given in the question in liter, so no need to divide also. So 1 by volume in liter. Okay, we are putting the volume in liter. So only ml case we need to divide, right? Fine. If this is the case, so given mass will be equal to what? 98 into 0.1. So 98 into 0.1, how much it is coming? 9.8. So my given mass will be 9.8 gram. This is the mass of the H2SO4 that should be present in the solution that we are trying to make. The solution that we are trying to make here. Okay. Now let's go back to our stock solution. The stock solution is 98% H2SO4 by mass. What does this mean? This means that 98 gram of H2SO4 is present in how much? 100 gram of solution. Is present in how much? 100 gram of solution. Okay, but 100 gram is the mass, na? I need the volume, because they are asking us what? They are asking us to find what? Volume, not the mass. So I'll convert this mass into volume. How do I convert? I have density. I'll convert this particular mass into volume, because they are asking us volume. How do I convert? I have density. So you know the conversion thing. If I have to convert, so we know density is equal to mass per unit volume, right? So my volume will be equal to, what is the mass? This is 100 gram. What is the density given? 1.80 gram per ml, right? This is the density given to us. If this is the density, if we calculate out, it is coming as 55.55 ml. Okay, this is the volume. So can I write that this 100, sorry, I didn't write the gram, no? So this 100 gram of the solution is actually 55.55 ml volume. So I can rewrite the statement as 98 gram of H2SO4 is present in how much? 55.55 ml of solution. These are same only. Okay. Previous one in terms of gram we wrote. This is we are writing in terms of volume. Both are the same. Right. So if 98 gram of H2SO4 is present in 55.55 ml of the solution, then how much actually we require? We require 9.8. So 9.8 gram, we require this much na, to prepare 0.1 molar. So 9.8 gram of H2SO4 will be present in how much ml of the solution? 55.55 divided by 98 into 9.8. This should be the calculation. Right? This should be the calculation. Or instead, you can also find directly. Simplify. Let's simplify. You can also calculate like that. Or let's simplify. 98 and 9.8. So if I divide that by 10. So will it not be 5.555 ml of solution? Now you will tell how this is coming. This is 98. Okay. This will be the volume. This is 9.8. So I will not divide that. So if I divide the volume with 10, how much I get? 5.555 ml. So 5.555 ml of the solution I need to take out from our stock solution in order to prepare the H2SO4 solution that they are asking. Okay, so my answer is 5.555. Option will be C. Clear? Next one. What is the mole fraction of solute? They are asking what? Mole fraction of the solute in 1.00 molar aqueous solution. Fine. What do you mean by 1.00 molar? Okay, this means 1.00 mole of solute is present in how much? 1 kg or 1000 gram of solvent. Now this is aqueous solution. So what is the solvent? Water. Sorry, why am I writing H2SO4? H2O, right? Solvent is water because this is aqueous solution. Done. From here, what information do I get? Mole of solute is how much? How much? 1 mole. 1 mole. Okay. Mole of solvent. What is the solvent? Water. Okay. Mole is what? Given mass by the molecular mass. Given mass is 1000 gram. Molecular mass of water is 18. Yesterday also we found this one. Okay. We have done this kind of question. 55.55 moles. Fine. Mole fraction of the solute. Sorry, not mole. So mole fraction of the solute, that is C, is equal to 1 divided by 1 plus 55.55. So what is this actually? 1 divided by 56.55. This is the mole fraction. So this comes out as 0.0176. The mole fraction is 0.0176. What is the option? The option is C, 0.0177. Right? So mole fraction of solute is nothing but mole of the solute divided by the total mole. So this is mole of the solute is 1 divided by the total mole, that is mole of solute plus mole of the solvent. Done. So this was the questions that I have given you yesterday to try on your own. I hope these are clear. So if you have any other further doubts, please send us a mail in this mail ID. We'll revert back to you. Thank you for joining the session.